This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. The most important distinction in this lesson is simple. A rafter tie and a collar tie may both look like horizontal pieces of lumber inside an attic, but they do different jobs in different parts of the roof. A rafter tie belongs low and resists outward wall spread. A collar tie belongs high and resists wind-uplift separation at the ridge. Mixing those jobs up can turn a framing decision that looks harmless into a structural problem. Picture the attic as a triangle divided into 3 horizontal zones. The bottom third is the gravity zone. The upper third is the wind zone. The middle area is where a contractor must be very careful about assuming that a prescriptive tie can simply be moved upward for more headroom. I put the key comparison on screen because the numbers are worth seeing side by side. The rafter tie is at least 2x4 nominal lumber, no more than 24 inches on center, and located in the bottom third of the rafter height. The collar tie is at least 1x4 nominal lumber, no more than 4 feet on center, and located in the upper third of the attic space. That is the memory map. Low, larger, and closer together for rafter ties. High, smaller, and farther apart for collar ties. To understand why the lower tie matters, imagine a stepladder standing on a slick floor. Push down at the top and the legs want to slide apart. The roof has the same basic geometric problem. Gravity loads travel down the sloped rafters, and part of that force pushes outward at the exterior bearing walls. That outward force is roof thrust. The rafter tie closes the bottom of the triangle. It works as a tension member between the opposing rafter sides so the walls are not left to resist that outward push by themselves. In ordinary ceiling framing, the ceiling joists may already be doing this job. When the ceiling joists run parallel to the rafters and are properly fastened to the rafters at the exterior wall, those joists can act as the required rafter ties. That is an important plan, reading, and field supervision point. The absence of a member labeled rafter tie does not automatically mean the roof is missing its tension system. I look at direction, continuity, location, and connection. Are the ceiling joists parallel to the rafters? Do they reach the opposing sides? Are they fastened at the heel joint where the joist or tie meets the rafter near the wall plate? The function matters more than the label. Now consider the opposite condition. Ceiling joists run perpendicular to the rafters, or a vaulted room has no continuous ceiling joist system, crossing from side to side. In that condition, the ceiling framing is not automatically completing the tension tie across the roof. I have to verify that the approved plans provide dedicated rafter ties or an engineered structural solution. The prescriptive rafter tie requirements are straightforward enough to memorize. Wood rafter ties are not less than 2x4 nominal lumber. They are spaced no more than 24 inches on center. They remain within the bottom third of the rafter height, measured vertically from the top of the wall plate toward the ridge. The location rule is the heart of the episode. The lower the tie stays, the more directly it restrains the outward movement at the rafter feet. As the tie moves upward, the section of rafter below it becomes a longer lever. That leverage increases the demand on the connection where the tie meets the rafter. This is why raising a tie is not just a finish decision. It changes the structural mechanics. A homeowner may see a few extra inches of ceiling height. I have to see a change force path and a change connection demand. Suppose a crew decides to raise the ties but keeps them inside the allowable bottom third. The roof may still remain within prescriptive framing, but the heel joint fastening requirement increases according to the California Residential Code adjustment table. The exact baseline fastening depends on factors such as roof slope, rafter spacing, roof span, and ground snow load. There is no honest one-size-fits-all nail count. The adjustment is based on the ratio between the tie height and the ridge height. At a tie height equal to 1/3 of the ridge height, the report identifies an adjustment factor of 1.5. If the baseline table calls for 6 nails, 6 multiplied by 1.5 gives 9 nails at that connection. I'm using that example to show the principle, not to create a universal fastening schedule. The approved plans and the applicable table control the actual connection. The placement decision on screen separates the prescriptive path from the engineered path. A tie at the wall plate or raised within the bottom third can remain prescriptive when all sizing, spacing, and adjusted connection requirements are satisfied. A tie moved above the bottom third, or a tie removed to open a vaulted space, crosses the prescriptive boundary. At that point, the ridge must be designed as a structural beam and supported as the engineered design requires. That boundary is easy to underestimate during remodeling. Imagine a contractor who removes ceiling joists from a room because the owner wants the roof framing exposed. Those joists may look like finished support, but if they are also acting as rafter ties, removing them opens the bottom of the roof triangle. The immediate condition is lost tension restraint. The likely next effect is greater outward demand at the walls and downward movement at the ridge. The proper response is not to add a light member near the peak and call the problem solved. The response is to stop, protect the work, and obtain an approved structural design. A structural ridge beam changes the way the roof carries gravity load. Instead of relying on opposing rafters and a low tension tie to form the prescriptive triangle, the ridge beam carries vertical load and transfers it to its supports. That usually means the beam and supports, posts, and supporting elements below must all be coordinated. The report does not support guessing those sizes in the field, and neither do I. This is exactly where standard prescriptive carpentry ends and engineered design begins. The heel joint deserves one more practical note. It is not just a place to put whatever nails are convenient. It is a highly loaded connection whose schedule changes with the roof geometry and loading assumptions. Before the joint becomes concealed, I want the crew working from the approved fastening requirement, and I want the inspection condition visible. Discovering a missing or underfastened heel connection after insulation and finishes is an avoidable sequencing failure. Now move your attention to the upper third of the attic. This is the collar tie zone. Collar ties connect opposing rafters near the ridge and resist wind-uplift forces that try to separate the rafters at the peak. They do not replace rafter ties, and they do not provide the low tension bridge that prevents wall spread. Wind over a roof can create suction on the exterior surface, while pressure inside the building pushes upward. The practical effect is an uplift demand on the roof assembly. At the ridge, that demand can try to pull the opposing rafters apart. A collar tie acts like a clamp across that upper joint. The California Residential Code requirements in the report are a minimum 1x4 nominal wood member, spacing no more than 4 feet on center, and placement in the upper third of the attic space. The code also permits a metal ridge strap in place of a wood collar tie. The report identifies a minimum strap width of 1 1/4 inches and a minimum thickness of 20 gauge nailed to the top edge of each opposing rafter. The easy mistake is to look at the collar tie and assume that any horizontal member must be helping with wall spread. Location defeats that assumption. A tie near the ridge does not close the bottom of the triangle where the outward thrust acts. It may secure the ridge against uplift separation, but it cannot be treated as the lower rafter tie. I use a simple phrase to keep the job straight. Belt low, collar high. The belt is the heavier rafter tie in the bottom third, holding the roof sides together against gravity thrust. The collar is the lighter tie in the upper third, holding the ridge joint together against wind uplift. The phrase is only a memory aid. The approved plans and code requirements still control the actual framing. Collar ties protect the ridge connection, but they are only one part of wind resistance. The entire roof assembly needs a continuous load path from the roof framing into the walls and down to the foundation. I think of that path as a chain. A strong link at the ridge does not help if the roof-to-wall connection is missing, and a strong roof-to-wall connection does not complete the job if the wall system is not tied into the supporting construction below. The California Residential Code requires loads to be transferred through a continuous path. For field supervision, that means I do not stop after confirming that the collar ties are present. I also verify the roof framing connections to the wall system and the connections below in accordance with the approved plans, applicable tables, and any engineered details. The exact hardware and fastening pattern depend on the design. I do not substitute a familiar connector merely because it looks close. This connection between ties and load path matters because the forces are different but coordinated. The rafter tie handles the horizontal component created by gravity in a prescriptive roof triangle. The collar tie handles separation at the ridge from uplift. The roof-to-wall and wall-to-foundation connections carry uplift demand through the building. Each component has a defined place in the force path. A useful inspection habit is to trace the load with your eyes before the work is covered. Start at the ridge, move down the rafters, check the heel joints. Check the roof-to-wall connections. Follow the wall framing toward the foundation. Then return to the attic triangle and confirm that the lower and upper ties are in their proper zones. That visual trace does not replace plans or calculations, but it helps reveal a missing link before concealment. Roof framing also brings an immediate safety responsibility. The source report identifies the current California fall protection trigger for employees engaged in residential type framing and for employees engaged in residential roofing on slopes from 0 in 12 through 7 in 12. Fall protection is required at a fall distance of 6 feet or more above a lower level. I put the current trigger on screen because outdated job site memory can be dangerous. The report specifically warns against relying on the former 15-foot assumption. For the covered residential framing and roofing work, the current trigger in the report is 6 feet. I want that number treated as a present supervision requirement, not as an optional best practice. The practical decision happens before a worker steps onto a top plate, joist, rafter, truss, or qualifying roof surface. I verify the fall distance and the planned protection system before exposure begins. I do not wait for a worker to improvise after climbing into position. The specific compliance system has to fit the work and the governing safety requirements. This safety rule is separate from the structural tie rules, but the supervision sequence overlaps. Roof ties, heel fasteners, ridge straps, and uplift connectors are often installed where a fall can occur. A contractor who plans only the framing details and ignores access and protection has not planned the work completely. I want you to leave with one clean mental picture. Divide the attic triangle into thirds. In the bottom third, the rafter tie, or a qualifying parallel ceiling joist, resists outward wall spread. Think 2x4 minimum and 24 inches on center maximum for a wood rafter tie. In the upper third, the collar tie resists wind uplift separation at the ridge. Think 1x4 minimum and 4 feet on center maximum, with an allowed ridge strap alternative. The middle and upper placement of a rafter tie is not a casual headroom adjustment. Once the tie moves above the bottom third, the prescriptive roof triangle is no longer the governing solution. A structural ridge beam and an engineered support path are required. Even inside the bottom third, raising the tie increases heel joint connection demand, so the fastening schedule must be adjusted rather than guessed. When I review this work, I ask 4 practical questions. What force is this member resisting? Is it in the correct third of the attic? Does its size, spacing, and connection match the approved requirement? Does the load path continue through the building? Those questions keep the framing discussion grounded in function instead of labels. This is a testable concept based on the Contractor State License Board study guide because it falls under roof framing, structural component recognition, plan coordination, inspection readiness, and safety. I am not predicting any individual exam question. I am giving you a framework that helps you reason through a roof framing condition without confusing 2 members that happen to look similar. There is an audio practice quiz for this specific episode on rafter ties, collar ties, and wind-uplift. It is audio-based, with the questions read aloud and your answer made by tapping, because I know you may be studying while driving, working, or moving from one job to the next. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about the material I covered. Subscribe so I can help you stay on track through every episode until you get your license. I am rooting for you, and I want the next study session to feel just as practical as this one.